Hi guys, welcome back to Calculi videos. In this video we're going to be talking about question 3 from 2018 AP Calculus Fair Response portion. In this problem we're giving this function g, also the first derivative of f. So when we look at this graph g, we see that some line segments and also this quadratic function, which is defined to be like this. Alright, so in part A we need to figure out f of -5 using the graph of g. And also we're given this info, which is f of 1 is equal to 3. So basically, the way we can figure out the value of f of -5 can be found by this formula, actually expression, mathematical expression. So f of -5 is going to be equal to f of 1 plus, using the definite integral from 1 to -5 g of x. Okay. So f of -5 is going to be equal to, we know the value of f of 1, which is 3. And I'm going to put minus because you see that the upper limit is less than the lower limit. In that case, we need to put minus, and we need to switch the limits. So we get from -5 to 1 g of x dx. So basically, this expression, integral from -5 to 1 g of x dx, is going to be the area under the curve. All right. So basically, that's going to be equal to 3 minus -9 minus 3/2 plus 1. Okay, so if you calculate the area under the curve from -5 to 1, right here from -5 to 1, okay, we're going to get this expression. So if you simplify this expression, we're going to get 3 plus 9 plus 3/2 minus 1, and it's going to be equal to 25 over 2. So that's the value of f of -5, 25 over 2. All right. And part B, it says evaluate the integral from 1 to 6 g of x dx. So before that, I need to wipe off the board. So part B, integral from 1 to 6 g of x dx. Okay. Alright, since g of x is the combination of linear and quadratic function, so I can decompose this entire definite integral into from 1 to 3 g of x dx. Remember that this is the property of definite integrals. And plus from 3 to 6 g of x dx. Alright, basically, between 1 and 3, it's pretty much a y equals 2 line. So gx is going to be equal to y equals 2 line. So I'm going to put it right here. So 1 to 3, 2 dx. And plus, between 3 and 6, the g of x is defined to be like this, which is a quadratic function, part of the quadratic function, to be precise. So 2 times x minus 4 squared dx from 3 to 6. Okay, so what we need to do, evaluate these two definite integrals and find the sum of them. So the first definite integral will be equal to 2x from 1 to 3. And plus the second definite integral is going to be equal to 2/3 times x minus 4 to the power of 3 from 3 to 6. So the way I arrived at this part, this answer is going to be through the u substitution. Okay, if you apply the u substitution, you're going to end up with this expression. All right, so this is going to be equal to 2 times 3 minus 2 times 1 plus, then you're going to put 2/3 times x minus 4. Actually, we're going to put 6 first. So we got 6 minus 4 cubed minus 2/3 times 3 minus 4 cubed. So let's simplify. 6 minus 2 plus 2/3 times, so 6 minus 4 is 2, 2 cubed is 8, so I'm going to put 8, and minus 2/3 times 3 minus 4 is -1. When you take the cube of it, you get -1, but there's another -1 being multiplied, so it's going to be equal to positive 2/3. And this expression is going to be equal to, when we simplify that, we get 10. Okay, that's the answer of part B. That's actually the value of this definite integral. Alright, so let's move on to part C. Before that, I need to clean up the board. Let me make this larger. So, alright, in part C, it says for -5 less than x less than 6, on what open intervals, if any, is the graph of f both increasing and concave? So, since we know that g of x is the first derivative of f of x, if f of x is increasing, that means g of x values have to be positive. Okay, if f of x is concave up, that means g of x, the first derivative of g of x has to be positive, bigger than 0. Okay, so let me use a different color. Okay, so the part C, alright, g of x values are positive between 0 and 1, so they are positive, and also g of x values are positive between 4 and 6. Okay, they're positive, which means f of x is increasing on these two time intervals. And also, when you closely look at between 0 and 1, that line segment has a slope of, actually it's going to have positive slope, which means g prime x values are positive. So, which means, so my conclusion, my summary will be, so the graph of f is increasing and concave up on 0 less than x less than 1, and also 4 less than x less than 6. It's increasing and concave up on these two intervals. Why? Because f prime x, which is equal to g of x is positive, and also f double prime x, which is equal to g prime x, is also positive on these two intervals. Alright, point of inflection is directly related to the second derivative. So basically, if I want to find the point of inflection, I need to take a look at the second derivative. So basically, when you look at the slope of this line, between 3 and 4, it's, the line is going down, the slope of the tangent line is going down from 3 to 4, and after 4, it becomes again positive. Okay, so right here it's negative, the slope of the tangent lines are negative, but right after 4 the slope of tangent lines are getting positive and positive, which means at x equals 4 the slope of at x equals 4 the g prime x values are changing from negative to positive. So that means f of x, so the part D, that means f of x has a point of inflection at x equals 4, since f double prime x, which is equal to g prime x, is changing sign at that x coordinate. Okay. Alright guys, thanks so much for watching. Don't forget to subscribe, like, share, and comment. See you in the next video. Bye-bye.